Good morning, everybody. Let me know if you are here by sending a little message in the chat. Good morning, good morning. Yay, people are here. I miss seeing faces, so let me know you're here by giving me a good morning in the chat. So this session is being recorded, and you will have, good morning, good morning, good morning. You will have access to all of my slides that I am presenting. That tiny URL there on the first slide is live now, so you can copy that down, and I will also put it in the app so you'll have access to it there as well. So this is being recorded, and I'm going to go ahead and get started. My presentation is Engineering in Elementary, COVID style or distance learning style. Engineering is really my favorite subject to teach. So a little bit about me. I am Danielle King. I actually live in Hellendale, but I teach in Barstow Unified. And I am an adventure-seeking, national park-loving, snake-raising wife and mother of twins whose goal is to help change the face of science teaching in elementary classrooms. I'm wearing my snake earrings today and my necklace here. We have 23 ball pythons that we are raising, all different morphs. And I believe that outdoor education is extremely important, so we strive to take our twins to as many national parks as possible. They've been to 42 of the 62 already. So the science and engineering practices are really what I want to focus on with this lesson, with this presentation. So asking questions, developing and using models, planning and carrying out investigations, analyzing and interpreting data, using mathematics and computational thinking, constructing explanations and designing solutions, which is my favorite one, engaging in argument from evidence, and obtaining, evaluating, and communicating information. So all of these are what the scientists do. These are the action pieces when you're teaching your science lessons. And engineering happens to be my very, very favorite science to teach. So this question was brought up in the app. How can we get kids engaged in engineering practices with no supplies to work with at home? And I really appreciate that this question was posed because it is very, very valid. We know that we don't know what students have at home. So basically my philosophy is, think about Cain's arcade. Cain used all kinds of trash. He used boxes and tape and random materials that he could find. And that's pretty much everything that I did in my classroom. Now, currently I'm not in the classroom. I am an instructional coach for science. But when I was, yes, Cain is amazing. When I was in the classroom, it was full of cardboard. It was full of things that you might have otherwise thrown away, plastic bottles, lots of random pieces, even broken toys. I would have students and their families bring in anything and everything that they may have thrown away that could be repurposed. And we would do just that. We would repurpose them into an engineering project. So Cain's Arcade is a really great example of that. I want to share something that a colleague shared with me recently. I believe it happened last week. She had a young lady who she's been attending classes virtually, but she really hasn't been participating at all. But recently, this teacher has amped up her science lessons. She's really doing a lot more in science. And now that little girl is actually communicating with the class. She's sharing with the class. That gave me goosebumps. This is difficult, teaching science during distance learning time. How do we reach them? It would break my heart if students started to dislike science because all they're seeing right now is reading and writing. All they're seeing is, let's read a little science article and then regurgitate the information later. I don't want to see that happen. And I know that we can make that not happen by using engineering at home. So the types of projects that students could do at home, and this is just using things that you would have thrown away. They could collect toilet paper tubes or paper towel tubes, and they could make roller coasters. This one here to the right, this would be a really great probability exercise. And all this requires are empty tubes and tape. They could collect those quite easily and then just use the walls in the house, use the chairs in the house. Anywhere that they can build these structures. Toilet paper tubes and paper towel tubes can also be used to make roller coasters. If you cut them in half and you place them together, you can make a ramp and make a roller coaster out of it as well. Another great resource are paper plates. Paper plates can be cut apart in different ways and stuck together with tape or glued together. And here you see that they've used the paper plates and the toilet paper and paper towel rolls and connected them to make a really cool roller coaster. So of course you would present your students with some kind of a challenge. Perhaps your roller coaster needs to have so many loops. Maybe it needs to be a total distance. Maybe you're wanting them to do some speed trials so they can incorporate their smart device, whatever they happen to have, and do some speed trials with that. Collecting data with all of these projects is extremely important and really easy to do. Straws and paper. NASA has a really excellent straw rocket lesson, and I love to use that one. And this is super easy. I did this with my own children. All you need is some paper. You roll it up on a pencil, make it nice and tight, and then you have a straw and you shoot it off the end of that straw. And then after they take some distance measurements and they record all of that data, then they modify that rocket and see how they can make it better. Add wings to it, maybe add some weight to it, a different cone on the end like you see here. So a lot of variety of modifications that the student could make with these straw rockets. I see a question here, how do we access the PowerPoint? I will go back to the beginning after I finish and you'll have the tiny URL, and I will also put it in the Whova app. Popsicle sticks and plastic spoons make great catapults. These are so much fun. Now, we know that not everybody may have popsicle sticks available to them, so they could use various other objects. Like you see, they've used an empty toilet paper tube here, or empty paper towel tubes here, and they could just use, it doesn't need to be plastic spoons. It could be a cooking spoon. It could be a metal spoon from the drawer, anything and everything that they can get a hold of. Like I said, I always collect trash, things that I could reuse, repurpose, and make engineering projects out of, like this here, strawberry basket. So this would be a really great distance data collecting experiment or engineering project. So they could design their catapult, one catapult, and then do some distance tests and then modify. I always had my students modify at least 3 times, and they needed to do at least 10 tests with each modification. So depending on how you want to do this, if you want to do this asynchronously or synchronously would be pretty amazing, but could probably get a bit chaotic. You could present the engineering project to them synchronously and then have them do it asynchronously. Perhaps somebody in the home could record what they're doing so they could share that later when they get back together with their classmates. And of course, you know, elementary students, they love to share anyway. So all of their successes and trials and tribulations, they're going to want to talk about. Balloons, rubber band cars, collect random trash. You can see that this one was made out of a juice box, some water bottle lids, and toothpicks. Now, balloons might be a little trickier depending on what students have available in the house. They may not have balloons available. So they could also do rubber bands. It's kind of hard to see the rubber band inside of this tube here, but this is a rubber band car. They could get really advanced, and like your upper elementary students, or if I have anybody joining me who is middle school or high school, Flipgrid, yes, Flipgrid is absolutely fantastic for recording their videos. They could get really advanced in their cars. You could maybe have a car designing contest. But this is definitely a really great way to have some fun. I encourage also all of my students to get their families involved. So these engineering projects are perfect for family involvement. These are perfect for connecting during this time when it's very hard to connect, and students are really missing that interaction, that social interaction. So if they're able to do these engineering projects at home, then they can connect with their classmates via the synchronous learning time when they can share their discoveries. Parachutes are another really super fun, easy thing that they can use. You can use paper towel, you can use trash bags, you could use tissue paper, coffee filters. You see coffee filters here. Super, super easy. Any kind of yarn or string can be used for those tension lines. And then they need to find something that's going to give them some kind of weight. They could use paper clips, and they could fashion those paper clips into little shapes, little figures. They could use, like some kids, this looks like it could be, I don't know, some kind of a little figurine, maybe even Lego, the little Lego guys. This person made little pipe cleaner people. So as long as they have something to create a weight, that's all that they need. And then you can have them, challenge them to create maybe different sizes of parachutes. So those would be their 3 different prototypes. Maybe they could create different shapes of parachutes. Maybe they want to do a circular, maybe they want to do rectangular, and then perhaps a square to see the difference with how the flight time is. Perhaps they want to create a parachute that's going to have the longest flight time. It's going to fall to the ground the slowest. So there's a variety of expectations that you can have. There's a variety of criteria that you can give them. You can also have them test just with different materials. Perhaps they want to do a 12-inch diameter circular parachute, but they test it with a paper towel, coffee filters, and a plastic bag. I always definitely recommend that they have at least 3 prototypes. Test each prototype at least 3 times. And whenever I'm doing these kinds of lessons, we talk about keeping very detailed notes, very detailed observations. I like them to talk about what they think worked and what didn't work. Why? Go in depth with these things, go into the argument and reasoning, go into the evidence so you can hit the CER when you're doing these engineering projects. What do you think happened? Why do you think that happened? What is your evidence from that? Make them be extremely detailed in their descriptions. Now, if you're working with younger students, you're going to have more drawings than anything else, but have them make their drawings very detailed. With the drawings, I would have all of them sketch out anything that they are going to be creating, whether it be a prototype or they're just doing their modification. Before that next step is allowed, they should be doing a sketch. You can also be teaching them their measurement skills because their sketches should be to scale. So the sooner they start working with that, the better. Boats are always fun and super easy because you can use really anything to try to see what floats and what doesn't float. You can do, you can make little paddle wheel boats. So I love this one with the spoons. You could also just cover up some pieces of cardboard with some duct tape or electrical tape because that will make it quite water resistant. You could even cover it with plastic wrap and then tape that plastic wrap really tightly, and that makes it pretty water resistant. So here we have just a water bottle, some bamboo skewers, there's a rubber band across here, and then the 2 spoon bowls. And when you spin that, when you twirl that, it puts tension on that rubber band, winds it up, and then when you release it, it's going to send it on its way. They could also make some sailboats, so they could use different materials to create a sail. They could then either use a straw to see how far they could blow that sailboat in a certain amount of time. They could use a fan to see how quickly that boat could travel down. So you have a time test there. They could even just take it outside, see if the breeze will take it. And if they did it outside, depending on the sail that they built, which sail was the most efficient to catch that wind, to take it down, whatever they're choosing to use. Now, when I did this in the classroom, I actually bought gutters, rain gutters, and sealed off the ends of the rain gutters with there's caps. And I just used a lot of hot glue and capped the ends of those. And then we did races. So I had 2 rain gutters next to each other, and the students raced down the middle. Now, students at home likely won't have rain gutters readily available, but if they do, that was a great way that they can test the speed of their boat. They can also just use the sink. They can use buckets. They could use the bathtub. And this one, sinking or floating. So they would make a boat to float and hold weight, and they're trying to hold as much weight as possible. This one can also be done really simply and with tinfoil. You could start them with that kind of a boat first. Ask them to get some tinfoil and shape it into what they think a boat shape might look like, and then they're going to drop pennies or some kind of lightweight onto that tinfoil, and they keep doing that until the boat gives out and it actually sinks. But that is a good starter project for anything like this, for a weight-bearing cargo load type boat. Shade structures. Now, any of these projects can be used from kindergarten all the way through high school. This one, I really love to see the progression of what students create as they're getting older. And shade structures can be created with any kind of material. They could go outside, collect some leaves, some sticks. You see here, there's random pieces of trash, some egg cartons and empty toilet paper tubes. We have some index cards, some empty bottles over here. This one, they've used some popsicle sticks, some straws, some paper. This one was probably done in the classroom because it looks like they have some UV beads here. So that makes it really fun if you have those at school. You can give them the UV beads and see how well the shade structure protects those beads from getting the sun. But the easier thing to do when they're at home is ask them to do this with ice. So they're taking an ice cube and they're going to put it underneath their shade structure, and they're going to take time trials to see how long it takes for that ice cube to melt. Now, they will also want to put one ice cube in the sun, so they're comparing how well does my shade structure keep the ice cold versus how fast it's going to melt in the sun. So really, really easy project. And again, any one of these projects can be done across all grade levels. And I think it would be really fun to connect with teachers from other grade levels and see how they've done these engineering projects and what their students have created, to see, like I said, to see the progression of the engineering as it grows. And if the younger students are seeing what the older students are creating, it could also spark some more interest and some more ideas, and vice versa. The older students might see some of the things that the younger students are creating and be quite impressed, I think. So I have created some engineering projects already that I have shared with teachers in my school district. When I go back to the beginning of the slideshow and you get the tiny URL, all of these links here are live links. So the Throwing Shade, Music for All, Float That Boat, and Renewable Energies are all engineering projects that are in slide form in the 5e format, and very super easy to do. Your students won't need to get really anything. They're just going to collect materials from around the house. I love to read other people's projects and then modify them and build them into slideshows, and that's what I've done here. Now, the renewable energy slideshow is a little bit different. So I mentioned in the introduction that, in my introduction for this lesson, that I did teach remotely with some students in China this year. And for those students, I did the renewables energies class. And so some of the materials that you'll see for those projects, may not be as readily available because I was teaching students in China. They were in their classroom and I was teaching remotely from here. So the directors of that school were able to get some materials, but some of the things that we did, you might recognize this. This is the windmill project from one of our rollouts. So this is one that my own children actually built. This is just done with a cork. We have a dowel, some skewers, and my children were trying to test different shapes of blades to see which one was most efficient. This is actually, okay, this one has the end piece on it. So this has the a spool, an empty spool, and then attached to that empty spool, you have a cup or this is a little Tupperware container that you would add weight to. And then we had a fan, and the fan would blow and turn this and try to raise this up, and my children would add extra weight to this. And that's what the students did in China. They would be adding weight to see which fan blade was most efficient at bringing that weight up. We also made some homemade water wheels. This is just done with an empty 2-liter bottle. These are index cards, and all we did to make them water resistant was wrap them with some plastic wrap and then used some electrical tape to attach them to the bottle. And then you mark one of those boxes so that when it comes around and you see that X, that's when you count the rotation. And we attached a weight to the bottom of it and different amounts of weight to see which kind of paddle was most efficient. So they modified these paddles. And then another project that's mentioned in the renewable energies is doing some solar ovens. So here we have a parabolic shape solar oven, very easy to make. This was just made with some poster board, and you can see it here in the back there. This is just made with some poster board that we shaped and cut some half circles here, wrapped it with some tin foil. A skewer would go through the center here, and then in the middle, you would maybe skewer a marshmallow or a hot dog, and then you can take this out in the sun and adjust it because you put this also into a box and that skewer rests on the box. So all of these projects are mentioned and described in the renewables energies slides. Teach Engineering is a fantastic resource, teachengineering.org. I use that resource a lot. It has given me many, many, many resources. Mr. Parr's Science Songs. I believe that the arts need to be brought into science. And pretty much with every science project I do, we sing. And Mr. Parr's Science Songs are fantastic. So you'll notice when you open any of these slides, woven in throughout the renewable energies, and at the end of each one of these, you're going to have some Mr. Parr's Science Songs that deal with, they relate with the project that's being done. Space Foundation Discovery Center has some wonderful, wonderful engineering projects. Of course, NASA STEM. I always use we love to build parachutes, and we love to drop them off high buildings. So great, great resources to use. I'm going to go ahead and go back to the beginning of this presentation. And now, if you would like to ask me questions, we don't have much time at all, but if you would like to ask me questions, please feel free to unmute, or you can ask them in the chat. So super easy. You want to keep this as easy as possible, because like I said, we don't know what they have or they don't have at home. Yes, I can put that in the chat. Absolutely. Let's see if I can copy it here. Let's see. I'll type it in. Okay, so there's the tiny URL. All right. How are you having students share their iterations with each other? So basically, during synchronous time, students would be showing whatever they have created or showing their maybe a video that they have made. Now, like I said, I am out of the classroom. So when I did this with my Chinese students, I was able to see them virtually via Zoom, so I could see the classroom that they were actually in, and they could share with me there. But for now, I would say that during your synchronous time, you have your students share their creations, and they talk about their creations. They need to have that time to discuss and to share and talk to each other and give each other critiques. They talk about what worked and what didn't work and why they think that was the case. These remind me of arts and crafts books I had when I was young. Lots of projects with thread bobbins and popsicle sticks. Yes, that's really the idea. And that's what I always did in my classroom. We had random items that parents would bring in, lots and lots of trash that I collected and kept in my classroom because there's so many projects you can do. PBS Design Squad is another really great resource for projects. And I use that one a lot. I'll put that here, PBS Design Squad. Another really great resource for projects. So again, that tiny URL is live. All of these slides are available for you to use. If you would like to change them in any way, just make a copy of them. And I do believe I have set it so that when you open it, it prompts you to make a copy anyway. What about having students share ideas on how they can best document their builds? Oh, that would be really good. So how did they keep notes on, so perhaps their drawings, their sketches, their prototype sketches, they could share those, how they kept track of that. Thank you, everybody. Seesaw can photo. I am not very familiar with Seesaw, but that would be pretty cool. Yes, bridges are definitely a super easy thing to do, and you can use many trash items for those. So just remember, and I always tell my students, don't throw things away. Take a look at them. How can you repurpose them? That cereal box, what else could you do with it? The water bottles, what else can you do with them? Milk jugs, what else can you do with them? Repurpose, repurpose, repurpose. Be environmentally conscious. Well, I appreciate all of you joining me. My email, let me go to my last slide here, and you can contact me with my email if you want to ask any questions or you have some other ideas. That's also the number to my office. Thank you, Dana. I miss all of you so much. I wish we were all together and we could actually build some things. Well, have fun at your next session. Thank you for joining me. Have a really great day. Thank you. Thank you. Enjoy the rest of your day. Get some really great ideas. Have a great day, everybody. Feel free to reach out to me if you want some more ideas, because I have plenty. Thank you.